Okay, so I think we can start. I'm Jason Wang from Red Hat, and today I will give a talk about the new features that will be included in the new versions called Virtio 1.1. And this presentation is a joint effort between Intel and Red Hat. And PV is the co-author of the slides, and Zhihong also gave several useful comments, so thanks for their great work. So first, let's see what is Virtio. So Virtio is invented by Rusty Russell. It was invented for easy mechanisms to provide virtual devices to guests. So it contains several different specific device formalizations such as networking, block, SCSI, and GPU, and etc. And standard drivers means that it can provide extreme compatibilities, which means, for example, if you have a single Virtio drivers in your VMs, theoretically it should run across different kinds of hypervisors, which has a standard Virtio backend. So here's the Virtio architecture. So at the lowest point, it provides several different kinds of transportations. For example, the most popular one is the PCI, and for ARM we have memory map I/O, and for IBM i390 we have channel I/O. So you can see that the idea here is trying to reuse the existing mature transportation implementations. This is not only for the easy software backend implementations. It can also allow kinds of hardware-based Virtio implementations. And in the middle, there are core device model, which concludes three important parts. The first is the what queues. It defines the what queues layouts and behaviors, and it also contains the feature bits, which will be used by some kinds of negotiations between the device and the driver. So the negotiation here means that only if a feature that has been negotiated or accepted by both device and the driver, it can be used. And the core device model also contains the config space, which is used for something like setting the base address of what queues or something like this. And on the top, it has several different device type implementations. For example, network, SCSI, or whatever. So why we need Virtio 1.1? So the answer is rather simple, the need for speed. So there are several requirements for the speed. For example, in recent years, 40 gig Ethernet cards or even 100 gig Ethernet cards has become a commodity. And we also received the requirement from NFV, and there are some vendors even trying to ship the hardware-based Virtio implementations. So all these trends requires more efficient and hardware-friendly implementations for Virtio. So the key to achieve the high speed is what queue layouts. So let's see what changes in the 1.1. So let's see the split with queues, which was used by Virtio 1.0. So in this layout, each what queues contains three different rings. One is the available rings, which is used by driver to submit requests to the device. And the available ring only contains the index of the descriptor, which points to the specific descriptor in the descriptory, which contains a flags of buffers, information such as the address, length, flags, or next. And it also has a user ring, which is used for the device to notify that which descriptors has been consumed. So during the benchmark, we see several issues of the split with queues. So for software backends, the major drawback is this design can result some kinds of bad cache utilizations. The main reason is that they can meet several cache misses per request. So you can see from this layout, because the metadata was scattered into 3 different places, it's not hard to imagine that each new access of a new locations will probably cause a cache miss. And the next issue is that the descriptor chain is not continuous in memory. So if you look at the descriptor format, there's a next field. So it's not a Boolean value. Instead, it's an index which can point to the, any other locations in the descriptor ring. So that means that if you have a descriptor chain, even if you can cache the first descriptor in the cache, you probably will miss it in next. And since we have so many different metadata in so many places, if there's a mismatch between the device and drivers, we can easily meet cache contentions in many places. And similar to what we had or what we meet in the software backend, we meet similar issues for hardware implementations. So it's not hard to see that for each packet, we probably need to issue several rounds of PCI transactions to get the whole metadata of a descriptor. So all this drives us to think about how to optimize the split vertical layouts. So here's come the new vertical layout for what L1.1. So we call it packet vertical. So the idea is rather simple. So instead of scatter the metadata into several different places, we will pack it all in a single descriptor ring. So this ring will be used by the device to submit the request, or also be used by the device to submit the completion of the descriptor tag to the driver. So you can see that there's a redesign of the descriptor format that still contains address length, and the descriptor ID was packaged in the descriptor 2, and it also contains a flags. In this flags, it also have 2 bits. One is the available bits, and another is the use bits, which is used to differ whether or not this descriptor is available for device or used for driver. So you can see that after we use the packet ring layout, we can just use 1 PCI transactions to get full metadata of the descriptor. And for the software backend, there are probably no lot cache misses, since after we read the first descriptors, the following descriptors is probably be cached by the CPU. So here is the performance result. So compared to the split verticals, we can get about 20% of the improvement, and in the PVP reference benchmark test. So if you are interested, you can go through this link to see the details. And the next interesting feature is the in-order completions. So before the Virtio 1.1, the spec does not forbid the out-of-order completions, which means descriptors may be completed out of order. One major reason for support such features is that the backend can try to implement some kinds of zero copy, and the hardware may be reorder the packets. And we decided to support this from the start of the packet ring because we need to keep capabilities with the split ring. But the side effect is that since we need to deal with something like ID allocators or whatever, something like this, it will result in a very complex driver because the driver could not have some easy assumptions of the device. So in order to have a simple device and driver implementations, and in order to let optimizations to be done easily, from Virtio 1.1 we introduce a new feature called in-order. So if in-order features has been negotiated a device must use buffers in the same orders in which it has been available. So this means consider you start with 1, 2, 3, 4 buffers to the device. Device must complete the buffers in order. And it allows extra optimizations. For example, after all the buffers has been consumed, you can just write, for example, the buffer 4 back to user read, which reduces lots of the memory pressures when you try to update the user read. And it also allows some specific driver-specific optimizations. For example, if you don't use distributed trains, you probably can do some fixed mapping between the variable index and the distributed index. So here's the result of the order completions, which was done by Marvin. So for PX, we can get about more than 20% of improvement, and for X, we can get about 6%, which is rather amazing. So, and the next interesting part is some vendors, for example, Intel, decide to ship some hardware-based implementations of Virtio. And the first interesting part is that the hardware's Virtio support this SRV capabilities. It means that it has PX, VX, and both of them are 100% of Virtio compatible. And PX can generate multiple Virtio VX. VX can serve for different containers or virtual machines or whatever else. It is pretty fit for the acceleration of the NFV, and you can only have one single Virtual Net drivers in your VM instance. Pretty cool. And next interesting part is the VDPA. So VDPA is short for vHost Data Path Acceleration. So the idea is just upload the data paths to the hardware and use a device specifically to control the to emulate the control paths. So in this case, the hardware knows all the data paths protocol of Virtio. So the hardware can DMA directly to the guest or cooperation with the guest Virtio driver in the data paths. And for control paths, all the commands will still tracked by QMO. And QMO will try to forward and abstract those operations through the vHost protocol and forwarding it to the device-specific VDPA driver through a new MDAG called vHost MDAG. So compared to the SRV-based solutions, this has several advantages. First is we can have full-level migration support because all the state of the Virtio was visible to QMO. And second is there will be no limitations of the maximum numbers of VX because we can use a device-specific way to configure Q pairs or something like this. And this also means that there's no need for something like SRV. So you can see that VDP is pretty fit for the transparent accelerations for the cloud users. There will be no need for a specific VX drivers in the guest, and you can get full support of something like that migrations, which is not good. And there are more features are coming. So first feature is the backup features. It allows Virtio to behave like a standby device for a virtual function. And the way to use this is to have a transparent failover drivers in guest. And before the migrations, management can hot unplug the VX. And the driver will switch to the Virtual Net data paths without any notice of the cloud users. And after the migration, the management can plug the VF back, and the driver will switch to the VF path. It's pretty impressive. And the next is the flags for the hardware backend. So Virtio is originally designed for software backend, so it does not consider several cases such as IO memory barriers, some DMA limitations. So we probably will need new flags to notify the driver that it was run in real hardware. So you need to take considerations about something like mandatory barriers, or you need to use something like DNA API correctly. And the next interesting feature is the notification date. So this is only for the packets what queues. So consider that compared to the split what queues, there will be no something like a tail pointers. So sometimes you probably want to prefetch several descriptors in one PCI transactions. So we probably need a hint of the tail pointers. So the idea is for us to piggyback the tail counters when writing the doorbell. And then the hardware can try to prefetch several descriptors for saving PCIe bandwidth. And this can get less pressures on the descriptor. So how to switch to the Virtio 1.1? So thanks to the negotiation mechanisms provided by Virtio, all extensions was added as new features. So compatibilities is maintained through the feature negotiation. So yeah, so new drivers on device will be fully compatible with the legacy drivers on device. So for the end users, if you have legacy drivers on device, there won't be any issues. And if you try to switch the new drivers on device, you will get a performance book. So you try it. So that's summary. So Virtio 1.1 is mainly for performance, mainly for hardware-friendly implementations of the Virtio backend. And if anyone has interest, you are welcome to join the party. And let's try to improve Virtio. So it's as simple as just open up issues in the GitHub, clone specs and patch specs, and have a discussion with the community members. And what's more important than that is we have a bi-weekly DPDK Virtio conference call. So if any of you want to attend this call, please contact me offline. And you are very welcome to propose your novel ideas. Thanks. Any questions?
有问题吗？欢迎提问。
谢谢。那个我用中文提问可以吗？可以啊。就是那个我刚才看那个，就是那个 Packet Function， 它对那个 PPS 性能好像是有一定的提升，然后对 PPS 性能有影响吗？
我能再重复一遍，你说的是指？
就是那个固态 1.1里面不是有一个那个 Packet Function 吗？就是那个特性最前面。对，就刚才那个图。
这个图是吧？
对。这个是 PPS 的，那个 PPS 的性能会有那个影响吗？
目前没有测试 PPS， 但是就是看应该取决于具体的这个应用吧，比如说是 TCP 还是 UDP 还是之类的，我们可以再做就是进一步的测试，对于传统的这些BPS 这些BPS 敏感的这些应用，我们可以做测试，但是目前没有测试，没有测试。
理论上是会有提高吗？还是说？
应该会有提高，但是也取决于你具体上面你跑的是什么类型的协议。
我能问一下，就是那个我看那个现在社区里 BK 社区里有1.1的 patch 了，但是还没有合到那个master 分支，这个是打算什么时候合？这个应该是
我们应该就是现在工作应该让尽快别合并，可能是在下一个release吧。我目前的计划是这样。我先就。
还有一个问题就是那个VDPA 那个技术，就是我看下一个议题也讲，就是那个的话，就是即使是没有合入那个Virtio 1.1的那个驱动，就是不使用Virtio 1.1的特性，应该 VDPA 也是支持的。
也是支持。
好，谢谢。
还有别的问题吗？
您的 slide 里面，您的 slide 提到了 Virtio 1.1的实现有硬件的那个实现，那个硬件指的是什么？是特殊的硬件吗？还是？
这个也可以由Wang的人回答，应该是特殊的，就是类似特殊的硬件吧，就是完全支持Virtio在硬件上支持。
是要插张卡吗？还是机器到出版吗？
这个最好你可以问一下英特尔的同事，这个是具体的实现细节啊。
是吧？谢谢。
就是我也用中文提问吧，就是说那个，因为昨天去参加像 Linux Conference 嘛，然后我是听到有 Scalable I/O 的一个计划嘛，所以我想问一下，就是因为现在基本上我听下来就是说1.1它是更加多的是针对于你 data path 嘛的，那就是如果就是后期的话，比如说想去支持 Scalable I/O 的一些特性的话，是不是就是说这一块也会在社区的 proposal 的这个计划里面？
对，这应该有一个融合，就是比如说 VDK，我个人理解 VDK，它可能就是一个很典型的需要就是，如果有 Scalable I/O 支持的话 ，VDK 的话会更有效。比如说你可以有一个网卡承载上千个队列，然后每个队列通过 Scalable I/O 的方式 ，MDAV 的方式 pass through 给不同的 guest。据我了解应该是在计划中，应该是英特尔计划。
Currently, some of the NICs support what I call as the tape mode, wherein multiple packets are transferred using a single descriptor. Does what I 1.1 support that?
Probably not. Yeah, we don't support, but we receive several feedbacks from very unique vendors. For example, Manox, Intel, National. So, if you want to have propose such kinds of layout, you can join or set patches and we can improve it.
Okay, great, thank you.
你好，我问一个问题，就是你刚才在这里面提到，在 VTP 的介绍里面有一个没有 VF 的这个限制，我理解这个是指的没有 VF 个数的限制吗？这个是怎么做到的？
它不是通过，就是说它不应该，我的理解，因为它不是通过，它可以不通过 SRV， 它通过一个设备 specific 的方式，比如说，像刚才这个同时提到的，就是说，比如说这种 scalable I/O 的方式，或者是反正就是，你只要有一种方式能把你这个队列，单独的队列或者 Q pair 或者一部分 Q pair 一部分资源传送给 guest， 让 guest 知道我只用这些。就可以。
就是说最终的这个可能不是个 VF 的形式，但是
不一定是 VF 的形式。
OK， 那就是说虚拟机里面这个虚拟网卡的数量在主机上其实还是受硬件限制。
对，受硬件限制，你也不排除就是说这是另外一个话题了，就是比如说如果你有一个 MDAV 的设备为 host， 你理论上你也可以有一个软件的后端去支持它，然后在硬件的线上做一些复用，这都是可以的。
谢谢。
我想要1.1，那就需要 guest 的那个来 support 它的1.1才可以使用对吧？
就是你要获得一些新的 feature 的话，需要 driver 的 support。
那如果对于 device 实现来说的话，那它就是说
device 也是，就是说你只有 device 跟 driver 都支持1.1，你才能得到这些新的这些特性和性能提升。
对，那它就是说呢，如果支持 latency 的，那我就需要 device 实现一套旧的1.0，然后再去实现一个新的1.1，对于 device 来说。
就是如果你要保证这个兼容性的话，比如说你要支持老的 driver， 或者你想跑在老的 device 上，你就需要去实现这些 legacy 的这些 feature。
好，谢谢。还有问题吗？好，谢谢，谢谢资深。